Hello everyone, today we are learning the subject of a circuit theory. Professor Sumera Ali. So welcome you all on this session, today's lecture. So we will see here the few numerical on the chapter of the electrical network parameters and the passive network. So in that we will see the numerical on the basis of the constant K and M derived methods related to all the filters. So let's start the numerical number 1. So what is mentioned here? Design a constant K, T section and the pi section of a low pass filter having a cutoff frequency of 2 kHz and the nominal characteristics impedance of 600 ohm. We need to find the frequency at which the filter offers the attenuation of 19.1 dB. So here let us clear. So designing part is related to the T section as well as the pi section. First, we should always remember which filter is used. Secondly, which section, that is nothing but the T and the pi. Which method, that is nothing but the constant K or the M derived. These things are too important, and later on which parameters are given, and last thing, that is nothing but which parameter you need to calculate. So see here in the A part, FC cutoff frequency is given 2 kHz. Z0 characteristics impedance 600 ohm is given. For the low pass filter is a low pass filter, and we need to find out the designing part component, that is nothing but LNC. So FC is equals to 1 by pi root of LC and Z0 is equals to root of L by C. So in this case, the characteristics impedance is directly given, the Z0 is directly given, but if not given, in that case, you can find with the help of this formula. So how we can find the LNC? So L is equals to Z0 divided by pi into FC. Z0 characteristics impedance 600 divided by pi into FC is nothing but the 2 kilohertz. So substitute the value of 2 into kilo, 10 to the power 3. So in this way, if you do with the calci, you will find the answer 95.54 millihenry. Second component is nothing but the capacitor. If you substitute, and we remember the inductor value will be in the milli always, and the capacitor value will be in the macro, and the inductor is measured in the henry and the capacitor in the farad. So substitute the value here. So just to take the macro, so we need to take here the 10 to the power minus 6 and here the pi into 2 into 10 to the power 3 into 600. Likewise, you can find with the help of calci, you can cross verify this answer. Second B part is nothing but the attenuation constant is given, that is a 19.1, that is in the form of a dB. And if you want to do the nipper, so yes, you can convert. So 1 dB or the attenuation in the dB is equals to 8.686 into attenuation in the nipper. So 19.1 is equals to 8.686 into alpha attenuation constant. Alpha is equals to 19.1, 8.686, you will be get 2.2 nipper. But if you want into the nipper, that will be 1 by 8.68 in the dB that you can find. Secondly, for the low pass filter, the attenuation constant will be alpha is equals to 2 into cos hyperbolic inverse f by fc. So f will be the normal frequency, fc is nothing but the cutoff frequency. Substitute the value here. Okay, and you will be find we need to calculate by the alpha, by the fc, you need to calculate the unknown parameter, that is nothing but the f. So here the f is equals to this 2.2 divided by the 2, 1.1 you will get, and you can do it, this 2.2 divided by this 2, you can get 1.1, and the cos inverse of that. So you will find the normal frequency is equals to 3.33 kilohertz. So this is the designing part in the T and the pi section. If you observe, this is a series arm, that is a L by 2, and this is also series arm L by 2, and the shunt arm is nothing but the capacitor. So whatever you got the value, just to 2 divided by 2, you will get 47.77 millihenry in the both the side. Capacitor will be the as it is, but if you go for the pi section, the inductor will be as it is, okay, but the capacitor value will be divided by 2. So whatever you got in the previous slide, so that will be divided by 2, so 0.131 microfarad in the both the side. So this is the designing part over the T and the pi section for this numerical. Now go for the second numerical. Let's start. So what is that? Design a constant K, T and the pi section having the high pass filter having a cutoff frequency of 10 kHz, characteristics impedance 600 ohm. A part is a B part is where to find the characteristics impedance as well as the phase constant of a frequency at a frequency of 25 kHz. next is nothing but calculate the attenuation of your the filter at a 5 kilohertz. So in short, you can say the first part is nothing but the designing part in the T and the pi section by concentrating the filter of your the high pass, and the method is nothing but the constant K. In the B part, you need to calculate the phase constant, another parameter. In the C, that is nothing but we will again calculate the attenuation constant. So A part, for the high pass filter, the frequency cutoff frequency FC is equals to 1 by 4 pi root of LC, and characteristics impedance Z0 is a root of L by C. So if you observe here the two cases, that is a T and the pi section, the series arm is a 2C, here also 2C, and the inductor will be the shunt arm. Whereas vice versa case, the capacitor will be the shunt arm, and the series arm and the inductors are the shunt arms. So 2L, 2L. So this value, don't write here the value. So after getting that value, you just substitute here in the T and the pi section. So how we can calculate the LNC? From the observing the equation, we can find the L is equals to Z0 divided by 4 pi FC, for the capacitor 1 by 4 pi FC Z0. Okay, so here you can take directly here for the micro, the 10 raised to the power minus 6. Here substitute the value of Z0, substitute the value of FC. So you will find the 4.77 millihenry for the inductor. Similarly, for the capacitor, substitute the value of the FC and the Z0, you will find 0.013 microfarad. So these value you can substitute in the above T and the pi section. If they are having directly the LNC, well and good. Otherwise, if divided by 2 or the multiply by 2, you can do it, and you can place the value there. For the B part, at a particular frequency, that is nothing but the 25 kilohertz, we need to calculate the characteristics impedance for the T and the pi section. So the formula related to that, Z0 root of 1 minus in bracket FC divided by F of whole square. So here 600 root of 1 minus, what is the cutoff frequency? That is a 10 kilohertz. What is the normal frequency at a particular frequency? 25 kilo. KK will be cancelled out, 10 divided by 25 whole square. So that is subtracted with the 1. So you will get a root of that is 0.84. So be remember 600 is multiplied with the root of 0.84. So you will get 545 ohm. Here in the opposite vice versa case, that is 600 divided by root of so and so, this part. So here will be 0.84. You will get as 661 ohm. Now this second is the phase constant beta. Beta is equals to 2 sine inverse of Fc by F. F is the cutoff frequency, F is a normal frequency. Substitute the value, you will get the 47.2 degree. But if you want in the radians, you will get as a 0.82 radians. Last C part is nothing but at a particular frequency, we need to calculate the attenuation constant. So alpha is equals to 2 cos hyperbolic inverse of Fc by F. So what is my Fc? Fc is nothing but again the 10K. And what is my F? That is nothing but the 5K here. So in this way, you will get the 2.6 nipper. That is the attenuation constant in this case. We will go for the numerical number 3. So what is the first case? The resonance frequency F0 is equals to root of F1 and F2. Two values are given. F1 is a 750 and F2 is a 4250. So if you substitute, you will get this hertz with the help of calculus. That will be 1.78 kilohertz. You can convert it. The series arm of a total inductance, that is nothing but the L1. L1 is equals to Z0 divided by pi into F2 minus of F1. So what is my Z0 given in the numerical 250, and what is F2? 4250 minus of 750 likewise, and the pi is also there. So you will get 22.70 millihenry. Again, the shunt arm inductance is denoted by L2. So Z0 into F2 minus F1 divided by 4 pi F1 and F2. So here Z0 is a 250, and the difference between these two frequencies is nothing but the 3500. How we got this 4250 minus of 750? So similarly here multiply, you will get 21.84 millihenry. Come towards the series arm total capacitance C1 and the shunt arm total capacitance denoted by the C2. So C1 is equals to F2 minus F1 divided by 4 pi Z0 F1 F2. Here difference will be 3500. Here will be the 4 pi 250 and 750 and 4250. So here you will get 0.34 microfarad. 0.24 microfarad. So shunt arm denoted by C2 1 by pi Z0 F2 minus F1. So 250 pi into difference, so 0.36. We remember capacitor value will be in the microfarad. So in this way, we have calculated the T and the pi section related to the band pass filter. So this is the final circuitry of the T and the pi. We have designed the circuitry. We have used the method of the constant K. We have used the band pass filter of a T and the pi section. So in this way, we have done. We have studied, we have seen the numerical related to the filters by using the constant K methods in the electrical parameters. Thank you so much.